All right, 20-second review of yesterday. Tanim and I hopped on scales when we are not interacting with each other. My diagram, 1060 up, 1060 down. Tanim, 660 up, 660 down. Then we interacted with each other. That's an interaction internal to the system. So it doesn't affect any of the other interactions. We still saw that the scales had a combined reading in the ballpark of 1720. That's how math works, okay? Scales still had a combined reading of 1720. The suggestion is that the smoosh-poosh interaction for the system and the gravitational interaction with the system are unchanged by interactions within the system, okay? Eventually we got around to an understanding that my mass is not changing, Tanim's mass is not changing, therefore our gravitational force arrows are unlikely to have different values. That the 860s that are the scale readings relate to the interactions with the scales, okay? So interaction between Harding and scale 2, 860, interaction between Tanim and scale 1, 860. The changes in the scale readings were down to the fact that I was pushing down on Tanim with 200 newtons of force, but the long walk to get to the visual fun was if I'm pushing down on Tanim with 200 newtons of force, Tanim's pushing up on me with 200 newtons of force. That forces, forces come in pairs. An interaction between two objects is one thing. It's an interaction. The size of that interaction here is 200 newtons. But then we display that as separate arrows on these two diagrams. So F, T, comma, H, F, H, comma, T. That was kind of the long story short with that. So where I think we're going to go next is here. Let me get rid of this. What the heck is the point of that? There we go. So I've got this set up in front of Alicio here, okay? And if I zoom in really close, move your head there. There's a camera behind you. Okay, so we can see here. This scale reads 20 newtons. It reads 20 newtons because hanging from it, I've got 1, 2, 3, 4. You can't see that. Can somebody, hey, Nyberg, can you be a deer and drop the shade back there? So much better, Mr. Harding. Thank you. Okay. So you can see this one's number 3. It's 500 grams. Each of these is 500 grams. Okay. Maybe just write the numbers on it, you jabroni. Draw. Yeah. So here's number 4, number 3, number 2. What? What? Why? 1. Okay. So that's what that looks like. So objects 1, 2, 3, and 4 are 500 gram masses. And what I'm looking for you to do, I think, is grab a big old whiteboard. We got one behind Weimar still, or did you clean those up the other day? Okay, so grab your family a whiteboard, get to work on the system schema. Now, hey, this whole thing going on here, let's just model that with one system schema. Don't draw a separate system schema for each object. You have a lot of overlap, okay? So system schema for this whole mass chain thing. And then free body diagrams for object 1, object 2, object 3, and object 4. Mr. Harding, that's not how quadrants work. Oh, well, we'll make it work. So this all goes on a whiteboard. Yeah, you can do that. So object 1, object 2, object 3, object 4. It's just goofy because it's not actually numbered like quadrants, right? Let me do it. I'm going to do it mathy because you're all a bunch of mathletes. There we go. 1, 2, 3, 4.
Thank you.
Lowest mother loves mine. Your diagrams need not be scaled. I don't need you to like scale your arrows, but you need to think about the number values of the arrows. I'm having you consider system schema, so you're thinking about the number of arrows as well. So this is a mass chain here. My strongest advice would be that you first draw object number 4 with a free body diagram, I should say. System schema for the whole shebang. Maybe start with the free body diagram of 4.
It's my first cup of the day, Mr. Harding.
What?
Yeah.
You said the check.
There. It's okay. That $5 won't hurt your grade too bad. So where you want to go in the physics need to know is a thing called lab analysis.
I'm going to put it up here. No, that's it. Wait, what do you mean system schema?
For all those objects are.
Bro, did you ball or you just know people that ball?
Oh, this is Kate's ex-boyfriend's sweatshirt that he gave to her.
Perfect.
I got like a Big Your Vines thing too.
Congrats to her on
I know.
soccer players.
No, it's not Jalen. It's another one. I got Nick Fair like a Big Your Vines thing though. I'll wear it tomorrow or something. Maybe I'll make. Get him.
That will work.
No, this is like he gave them. This like was a gift to her. You know? So it wasn't like.
I know those things are still out there in the world. My favorite soccer T-shirt of all time. I don't know where it is, but
Yeah. Someone has it. Wait, I'll here. Watch this. Watch this. Differentiate between the next.
Sorry.
what? Cool.
Yeah.
Wait, so we're doing it. No. Quadrant 2. This is quadrant 1. I'm just
Oh yeah.
2. Quadrant 3. Delete that. Quadrant 4. 1. One arrow.
So we got.
Wait, what are we supposed to do? FPD for.
We have E. We have 4. Now we're doing the fourth one on 2. Now we're doing 3. Sorry.
What?
Now we're doing.
So you're drawing system schema, free body diagrams for everything. I'm asking for your free body diagram for number 4 in pair deck as well.
You say start with number 4. You say start with number 4 for free body diagram. Or was I just?
So it's like system schema for the whole shebang. And then when you're doing free body diagram, and then you start with 4 on the bottom. Draw that one first. I think that one's most reasonable, maybe.
Wait, are they all connected?
What force is 4 putting on the scale? Or is it not the interaction? So if I move right on the object, if I move other object, would number 4 be?
Yeah.
So it's only 1 in there.
So are
You might be right.
no, you're probably right. Would these all be put to the scale too?
Kind of small.
You?
Yes.
Wouldn't no, your big brain. Just the scale? So should I draw this?
Missing any race thing. Technically, mean, it is, but it's not any relevant there. So you don't really need it.
Quincy here? Quincy's here. How's it going, Quincy?
Where are forces of gravity?
I never know.
Attention force?
Oh, gosh.
There's 50 donut that that is the must.
So water has three forces. So they all have a force of gravity. They all have gravity.
Next scale.
This isn't that. It's the
I don't know how many.
Hard and some of the donuts.
yes, it was depending on the mass. They're all 500 grams. So let's start with the easiest one, which is 4.
Yeah, maybe.
So 4 has
Or
So we'll have
how many grams? Ah,
it's 5 units down. That's in the external force. So there has to be an equal force value. Center of the body has to be my line is FT.
The who? What do you need? No. Unless you're talking about topology.
I disagree.
What do you call a person that steals cups?
We have 2 forces down.
A mother.
These 2 would equal that. Do you want us to put the arrows in the origin, or can we like attach one to another?
Do we talk about fat dots in here?
Connect the dots.
Yeah.
Fat dots.
Yeah, they would be the same.
FT.
And then the other one would be F1. And then you can just do like really weird, just like
Yes.
No, that's not. I think that's one way of putting it. What's going on?
There it is, right?
Yeah.
We have
Because the other force of tension now would be 10.
There's one.
It would be a combination of gravity.
So what is it trying to be?
Hey friends, I'm looking for you to drop a free body diagram in number, in the pair deck, which is shorter. Drop in your free body diagram for number 4, yo.
So one of them would be equivalent to 2.
But it's still not
Yeah, one of them is.
So you have only that 4 length and the other one will be equivalent to.
first person. Not touching technically. We tried.
One will be 500 left.
Are you trying to justify dating?
5 years.
Oh my God!
What? Put gravity in the object. Because gravity is 2 experiencing.
What is your
5 units, right? So which one is
object?
What are the
Gravity's
500 grams?
How many years? Okay, that's 4. How many newtons is this?
Is there anything else connected to the object?
Be careful about scaling. I don't know how many newtons is this.
How many newtons is the tension force up on object 2?
I did 1000. Oh, no, not 10.
Yes.
Make it.
So therefore, there has to be something to counteract that, which is this one.
5.
These forces of tension are equal to each other.
5 and 10.
Yeah, this one is equal to that.
10, and then 5.
And then you have the time, so there's a 15. And then we just had
This is
process where
F. Wait, really? Wait a
Since you told me what to do, basically.
I don't know about your
15.
These glasses.
I think that's how it works.
Three.
Will you explain?
Stop being so confident.
He has every right to know my middle name.
I would like for you to compare it
This
to
one's
my
still
opinion.
1 point to my last.
That's like
So this is now it's the pair deck.
Oh yeah, you could create the I'm kidding. My dog's
Alright, so my question for you, and this is why I wanted you to focus your attention on 4 to start with, is how does the experience of this 500 gram mass hanging here directly from the scale compare to this 500 gram mass hanging from the bottom of the scale? Who's got a tougher job here? Okay, that's what I need you to kind of consider with your neighbor. The scale here, you get a 0. The scale here reads 5 with this 500 gram mass hanging here. So, like, long story short, is this guy's day made more difficult by the presence of the other things in the chain? Okay, how do those situations compare?
You can act the other way.
I want you guys solve one major
Because we have like put what was it? This one?
All right. System schema wise, what else do I need here? Alicia says scale. Got it. There's a scale. What is our indication for non-gravitational interactions? Sorry, so here's what I'm saying. Other than gravitation, what are we usually looking for to declare things to be interacting with each other? Touching. Okay, is anything touching the scale?
surface. Table.
The table is touching that scale. I mean, I would argue scale is touching the post. Touching 1. Object 1 here. Okay. Ooh, a fly. Okay. Anything else touching object 1? Object 2. Okay. So 1 to 2, they're touching. Okay. Anything else touching 2? 3. They're touching. 3. Anything else touching 3? 4. They're touching. Okay. Okay then. So here's my question to you. These 3 lines that I've just drawn in green, like, which is the most strenuous, if that's what I'm asking? Like, which of those is the most challenging interactions to maintain there, okay? Requires the most fuerte, all right? So, or do you consider each of those smoosh pushes to be identical? Which, are they equally difficult to maintain, or are some of those difficulter, all right? You two? Is that what you're asking? No, okay, fair enough. All right. Usually at our house, if somebody says it's not you, then it means you farted.
Sometimes it smells like cauliflower in here. Yesterday it really did. So maybe
That's because I farted. All right, so number 4. We got number 4 here. Suggestion from the system schema is I should have how many arrows here? 2, right? I got 2 lines connecting to 4. All right, so I'm going to draw a downward arrow. That's FG 4 comma. Why am I doing this? I made you pair deck this. What the heck? Why'd you make us pair deck it? You're not going to
choose mine.
respect
Really good.
our things here, okay?
500 new.
I got a tension weight hook, 500 newtons. Keep in mind I'm slightly over 1,000 newtons myself. 500 newtons, popular
Go check out mine.
number.
Keep going.
Odell Beckham Jr.
Keep going. I have it all labeled and everything.
20 newtons.
Yes, I am.
20 newtons.
That one.
5 newtons. She keeps on passing me by. So, okay. So something that's making me sad in my heart right now. We did this lab, and some of you have 5s out of 10 on it. Go back and fix that in the Canvas show. But the whole point of that was to land on these equations. These should be burned into your retina somewhere, so everybody stare at these for 30 seconds in silence. You should understand silence in here. And then stare at the ceiling and tell me what color the print is. Ready? Go. Not if you stare at the ceiling, not if you stared at it for 30 seconds. Do it again. Don't stare at me, Dylan.
Whoa. The background's like pink,
Kinda.
but it's still
All right, there we go. So, long story short, 10 newtons per kilogram, 1 newton per 100 grams. These are how many gram thingies? 500 grams. So the force there would be the 5 newtons, okay? 5 newtons. We got 4 comma scale. We got 4 comma earth, all right? So back to that action. Oh my gosh. Going down and mass chain. All right. 4 comma earth, upward arrow. F T or smoosh poosh. You be the judge. 4 comma 3. All right. Now we know the gravitational force is 5 because it's 500 grams. This smoosh poosh must be balancing that out. So I'm going to start to label some of these lines here. We talked about this the other day, making the system schema quantitative. This smoosh poosh is 5 newtons. This gravitational interaction is 5 newtons. This gravitational interaction is 5 newtons. This gravitational interaction is 5 newtons. Now, don't go through and label those smoosh pushes quite yet because you've got things pointing in different directions. And, we got to take that into account here. So this is number 4. All right. Now, if you look at number 3, I've identified the value of 2 out of the 3 interactions here. Okay. 5 and 5, that should balance right there, right, Mr. Harding? Well, again, you got to consider the direction of the interaction. So for object 3, what is now? Geez, get better at this. All right, for object 3, what do you got? Okay, get after it there. What? Nope. Come on, Harding. Stupid. Why is that button so close to that button? Oh. Oh. Poop. I'm trying to zero out the scale here. Well, yeah, but that's just collateral damage. All right. So again, make sure that your free body diagram for 3 agrees with what we're saying so far about the system schema. Also, if you got arrows pointing in the same direction, we talked about fattening up the dots yesterday, I think. That allows you to make more arrows parallel to each other, okay? Hashtag fat dots. Oh, that's dumb. Jeez, Harding. All right. Try that again. Got it. All right. Dummy. Oh, so bad at this. Okay. All right. What are our friends saying over on the internet? We've got. Whoa. Okay. So we got 10 newtons up, 5 newtons down, 5 newtons down. So the 10 newtons up is 3,2. Downwards, we got 3,4 and 3, earth. 5 up, 5 down. So 5 up, object 3, object 2. 5 down, object 3, earth. 10 down, object 3, object 4. So when you look at those values, my friend that's still working on this, make sure that in the end you end up with a number 3 that is CVPM. 10 newton up, 5 newton down, 5 newton down. 10 newton up, 5 newton down, 5 newton down. Okay. So it looks like you're on playing with us here. Let's go. Mr. Harding is too lazy to draw, so I'm just going to do this. Boop. And boop. All right. So for object 3, now presently there are 1, 2, 3, 4, 5 newton arrows on here. My question to you is this: of these 1, 2, 3, 4, 5 newton arrows, which, if any of those, are paired forces? Okay, a la the Tanim and Mr. Harding thing from yesterday. So run that by your neighbor really quick. We're not going to bother with putting it into the pair deck. Are any of those paired forces, right? Those paired forces, they got same amount, point in different ways. All right. So let's drop a little marker in here for this. All right. When forces are part of a pair, that means that they both relate to the same interaction. So I'm going to put a yellow star here on this line. That's a 5 Newton interaction between 3 and 4. Half of that pair shows up. That's a terrible star. There we go. There's one half of the pair because it's called 4, 3. The other half of the pair, that's going to be this 5 Newton force right down here. That's called 3, 4. That's kind of your check for our forces part of the same interaction. The feeler dealer should just flop, okay? And then you know it's a pair, okay? So let's write that down on here somewhere. Well, what? I didn't do the pair? Did I not pull out a pair in here?
Yes, he did. He
Twice.
had a pair and he went,
And you near stepped on my joke, didn't you? Or was it Dylan? It was Dylan.
what did I do?
Oh, okay, it was you near. Yeah.
Blaming me. Always
So forces come in pairs. And so if you have FA comma B, and then you would have FB comma A. Okay, so those are paired forces. That's why 4, 3, 3, 4, those are part of the same force pair. There are 3 arrows that are 5 newtons and pointing the opposite direction of this upward 5 newtons. But that's the pair because they relate to the same interaction over here. All right, so then moving on here, we can identify that the interaction between 2 and 3 is stronger like we anticipated. It's 10 newtons of force, okay? So move on to that in your pair deck. Object 2, what's that pair deck force free body diagram words physics talking look like? Red basket. Thanks, Grace.
Grace.
Do you know Grace? Isn't she great?
Grace, great.
She's great.
I know everyone this morning. I know who you are. You're sassy today. Why are you so sassy today?
Do you know that kid outside smoking a cigarette, talking on his cell phone?
Probably.
Oh, he's part of the construction. It's okay. He's allowed to. Awesome. I think that's a separate nation state inside that fence there. It's like Guantanamo Bay in Cuba. That's considered city construction territory. Oh, yeah.
Are you not allowed to smoke at all? Or are they like...
So like the teacher lounge, the old school teacher lounge, like that used to be the smoking lounge. And actually, I think when like in the olden times, there was actually a smoking room for students too here.
What?
Yeah.
What?
So there were a couple of rooms that,
I mean,
not this room. No,
Yeah.
like an intentional one. Like we provided you with, well, I guess we still
Might
do.
as well flush your lungs down the toilet too.
Yeah, well, that's vaping, bro. That's different. We're just talking about lung cancer when you're 60. All right.
Yeah, they're only pushing the girls' bathroom.
Of 1%.
Yeah, they're all in
Yeah, they're all in the girls' bathroom.
They're all the guys.
On the main hallway. The 2 bathrooms that are open. Only on the girls. I don't think I've ever walked into a bathroom.
Are you food shy? No, shy.
Is this 9th grade?
You drink so much water.
¿Tienes cargador para Yanir? All right, still waiting on a few friends. Hey, friends. Specifically, I don't want to call anybody out, but hey, fatten up your dots. Some of you are bending arrows. Don't be bending arrows.
My arrows are
Yeah.
The line not matter. It's just where the arrow ends. It's just the direction. Because then there's the starting point and end point. So you can just,
no.
Don't bend your
I
arrow.
could be like,
as long as the arrow
College Board would like
Don't be a
minus
smart
one.
ass.
So
Would that make them angry?
wouldn't make them angry. It'd make them take points away from you.
Dang.
They're indifferent to your
Hey Leo, what are you doing tomorrow?
feelings.
Working.
What if I cross it?
Oh, you already are?
Yo, there's text tools,
Are you
donkeys.
running? Hosting?
Why would you?
Wow.
I'll be late today.
I'm judging you. Taneem, if I'm commenting on it, it's probably yours. So just know that when we're pair decking things. All right. Boop.
It's not Andrew.
Boop.
Where is Andrew? My favorite.
Andrew likes Ben arrows too. Okay, so boop. Yo, catch up, man. I hit that. All right. So we've got 2,3 upwards, 15 newtons. Got an FG of 5. We got a smoosh push of 10 down. Who's got all my labeling for me?
Me.
There we go. 2,1, 2, earth, 2,3. Okay. So these are all of differing values. Boop. Drop this in here. Boop. Whoa, that's big. There we go. I smooshed it. All right. So 15 newtons up, 10 newtons down. So now I see two 10 Newton forces. So I'm going to put 2 ticks on there. Okay, they're the same amount. Are they a force pair? Run that by your neighbor really quick. Porque. And so again, our tell us to look at the feeler dealer. 3,2, 2,3. Those both relate to this line. I'm going to give it a golden horseshoe. So I'm going to put a golden horseshoe.
We give a golden horseshoe.
Both.
That's the Christmas tree clock, and then we get $5.
There you go, golden horseshoe. All right, that leaves us with 1 and done. So, boop. Number 1, we've got 5 newtons down. That's FG 1, E. We've got 15 newtons down. That's F smoosh push 1, 2. 1, 2, 3 tick marks. 1, 2, 3 tick marks. Because again, we can see over here, that is the most strenuous of the interactions between objects 1, 2, 3, and 4. Is the one that happens between 1 and 2, because 1's got a lot of work to do. Like if you can imagine, these are all mountain climbers hanging off the edge of the mountain. 1's having a tough day trying to hold everybody else up there. So let's give that diamond. Oh, green diamond, apparently. Okay. So fun shapes are used to indicate that forces are halves of the same pair. And then this isn't balanced right now. It's only balanced if I have an upward force of 20 newtons. That would be F smoosh push 1, scale. Okay. And lo and behold, that is what the scale reads. The scale reads 20 newtons. Okay. So within this mass chain, we're seeing evidence of these different force pairs. And that's a really important problem-solving tool, okay? When you're dealing with force diagrams, being able to identify that objects that are interacting with each other are experiencing one thing. That one thing is an interaction. It shows up 2 places, okay? It's kind of like a pair of jeans. Go grab a pair of jeans. A pair of jeans is not 2 things. It's one thing called a pair. That's dumb, okay? Well, forces are part of an interaction. They're a force pair. They're really one thing. They're one interaction. But we just have separate legs. Somewhere the metaphor makes sense, I'm sure. Okay? So that's what's happening here in the mass chain. All right. Let's call that good on that. And then the last thing I'm going to ask you to look at today is this ranking task. Okay? Let me explain what's going on in this thing. So there are 8 figures, A through H, And in these 8 figures are various strings. They're connected to fixed objects like walls or ceilings, or in some cases, I want to break your Chromebook. In some cases, they are connected to other objects via strings. Okay, so I'm going to show you what. So, like, if you can kind of see down at the bottom there, G and H, those diagrams are terrible. What they are pretending to show is 2 equal massed objects located either side of a pulley like this. Okay, so they're wondering about the tension in that string. And hey, compare that to this setup where the string's attached to a fixed object and then passes over a pulley. So like, which one of those strings is under greater tension, more likely to break? Okay. In some cases, there's an additional force. So A is also being pulled to the right by 80 newtons. B is being pulled to the right by 45. D, there's somebody underneath it pushing up with 40 newtons of force. Okay. In E and F, you're asked about the uppermost string, but there's also something connected below. So there's all this business going on here. What I'd like you to do is take a gander at all those and then craft a ranking of this. Okay, and again, rankings go like A greater than B equal to C, such and such. Okay, something along those lines. So have a look at that. The weight of the object is included. So 20 newtons, 35, 80 newtons, 120 newtons. Your ranking is that rope R, greatest to least on tension. The tension in rope R. Okay, so we'll end with that ish. Emily Moore, use greater than or equal symbols. What are you doing?
No, I'm just kind of up there.
Yeah.
Which object is or just
So it's that rope R that we're asking about in G. I don't know if you can see the demo because it's forever away from you.
That's the problem.
Oh, that's
we have to rank them?
Yeah.
This makes it significantly more.
Look at you looking at it in the notebook. It's like that notebook works. That warms my heart. Yeah, if you're Chromebook savvy, this is in the notebook. You can just navigate to it via the canvas.
Yeah, they don't roll.
Oh yeah, that'd be smart. Hey, go ahead and have the slacker in your group clean the whiteboard, put it back where the whiteboards go.
Yeah.
I'm not saying you're the slacker, I'm saying you should have made the slacker.
All right, Levi. 3 times.
Hasta luego.
Clean it.
Mi amigos. And again, a reminder, I moved the mastering assignment to Monday, so don't worry about it yet. Tomorrow you should be able to deal with all the problems that are on this.
I tried to. I got it.
You got them right already?
I got everything on the work.
Oh, okay. I like to do another day. Let's go with that. We'll do this tomorrow. We'll get this tomorrow.
Thank you.
Yeah, sorry about that.
Oh, you're fine.
Ooh. What's up?
So you sent me a link on the
It doesn't work. So in Canvas,
yeah.
look in the AP Physics Need to Knows, look for a link called Lab Analysis, and that's what it's supposed to go to.